Hi guys, look at my muscles. They're not much, but yeah, I just came to contest a bit earlier, likely 10 seconds earlier, 20 seconds. It's a rated division 2 for me. I'm an expert. I'll become specialist in this contest. Minus 200. Here we go. Am I visible well? Am I well visible? Am I be? Am I tired? Am I talking shit? Passing the ball. During the physical educational class, and students are lined up numbered from order from left to right. For each student, it's known that if they receive the ball, they will pass it either to the neighbor on the left or on the neighbor on the right. This is specified by string of SN characters. Each character on the string is either L or R, where SI is L and right. The student always passes the ball to the second and the last one of the list. The first student always passes to the ball to the second and last one to the second last. In other words, first is R and last is L always. Consider the following process. First, the first student receives the ball, then exactly n times the following occurs. The student who currently has the ball passes it to their neighbor. According to the rules described, ask determine how many students will receive the ball at least once during this process. So we have T. T can be big, N is just 50. Number of students. Second line contains a sequence of n integers. So who will get the ball first? The first student receives the ball. Then exactly n times. So you can stimulate it right entirely. You can just stimulate it entirely, and then you know who all will receive balls, right? So let's just stimulate that. Let's say received of n plus 1 be 0, like if someone has received or not. First guy already got it right. For int I equals to 0, I less than an I plus plus uh, cur plus equals to s of I equals to r means 1 else minus 1, and then received of cur equals to 1 and answer equals to 0 for int I equals to 0, I less than an I plus plus also plus equals to received of I equals to 1 return see out answer. We just simulated, we just passed the ball n times, and after passing the ball n times we are just trying to submit the solution. Right. right right 1 2 3 4 5 6. So why not everyone? Why did not? Why did it, I mean everyone should have received, right? Received of 0 equals to 1. What did I do? Okay, A was too easy. And then what about B? I took 3 minutes on that still. You have given an array consisting of n integers. While the array is empty, and operation is performed consisting of two steps. First, the maximum element in the array is chosen. If there are multiple maximums, the rightmost maximum is chosen. Then all elements after the chosen element, including it, are removed from the array. Your task is to calculate the number of operations that will be performed before the array becomes empty. So you want the maximum okay, and then that will be removed. So if you're coming from this side, okay, the whole maximum, the rightmost maximum, and then what? So the whole maximum, how do you see that? Whole maximum is nothing but the maximum from this side, and then you want the next maximum in here, and then you want the next maximum in here. Okay, just find the whole maximum and its index, and then before that try to find the whole maximum and then its index, and so on. That's it, right? Last maximum index, find that for everything, and then you're done. And size of array becomes just 1 0, you remove everything, right? It's brute force again. Let's just find the maximum's index, okay? We don't even need value, we just need maximum's index. Max equals to a of 0, let's say, and midx of 0 equals to 0, let's say. For int I equals to 1, I less than n, I plus plus. If a of I greater than or equals to max idx equals to 0, let's say, so far, okay? A of max idx, then max idx equals to I. Until here, midx equals to max idx. So now what do we do? Start from length equals to l equals to n, let's say, okay? While length greater than 0, what do we do? For this whole length, we try to find the maximum index, and then we chop till there. Int new l equals to m idx of l minus 1 plus 1, l equals to new l, answer plus plus, see out answer. So here you'll remove this one, and then you'll remove this one, and then you'll remove this one, right? Once you remove this one, among this length, we want to find the maximum, which is nothing but midx of l minus 1, and then new l will become just that much. We have to take array input. Alice, Bob, and Carol visit a spring to collect water. Alice visits every 8 days, Bob visits every B days, and Carol visits every C days. When only one person visits, they collect 6 liters of water. Multiple people visit, the water is divided equally. Two people take 3 liters each, and three people take 2 liters each. Your task is to calculate how much water Alice, Bob, and Carol collect over M days, starting from day one. How much each of them will collect, right? How much total will collect? We know it's 6 times M. Okay, let's just write those equations. Let's just write whatever we can write. How the splitage will happen is what we want to see here. So we want number of days A will go, only A will go, and number of days AB will go, only AB will go. Number of days all ABC will go. Okay, all ABC will go is, so it's like if you see number of days, you can know based on that you can know the split, right? If you know number of days for each of this shit, so one is like, let's say A1, ABC. Okay, what we want here is we want A intersection B intersection C, and we want A intersection B without C. See, intersections are easy to find. Intersections are easy to find. So which is nothing but A intersection B intersection minus A intersection B intersection C, right? So it's not that difficult. All these things are not that difficult. And just A equals to, see, in finding intersections is easy. Intersections is nothing but taking LCM among them. Okay? And once you know the LCM, then you can just divide the total M with that value. And now, what is only A being there? Only A being there is nothing but, you can split that into, so A being there, you can split that into A being there and B not there, C not there. Okay? Plus A being there, A and B being there, and C not being there. Plus A and C being there, and B not being there. Plus, yeah, that's it. Plus A, B, C all being there. Right? All are there. B is not there, C is not there. All these things are easy to compute. So to get this one, all these things are easy to compute. So what is this? A intersection B not being, C not being there. What is that? What that can be written as? It's nothing but A intersection B minus A intersection B intersection C. Okay? And even this will become plus A intersection C minus that. This minus and this minus will get cancelled. So we have this equation, let's say, okay? And if you see this one, A without B or C equals to A minus A intersection B minus A intersection C plus A intersection B intersection C. So we have this formula, and even for this we have formula. Just two things being there without the other one being there is uh, A intersection B minus A intersection B intersection C. So yeah, we can write for all of those things. Like how many things do we have? We have three here, we have three here, we have one here. We have three here, we have three possibilities here, we have one possibility here, right? So let's just do all of them. Okay? Int A B C M. C in A B C M. Okay? Int A B C equals to, I'll just keep AB equals to LCM of A comma B. And if you're worried about number of days, let's just divide that too. BC equals to, we want some other notation. ABC equals to m by LCM of a comma b, LCM of a comma b comma c, let's say, okay? AB equals to m by LCM of a comma b, BC equals to m by LCM of b comma c, AC equals to m by LCM of a comma c, okay? Int a equals to m by a, b equals to m by b, c equals to m by c. Okay, now we have seen the other formulas, right? Let's just go over all of them. Each of them being, so how many days this will add? How will the first one add up to? Int, let's just say x equals to 0, y equals to 0, z equals to 0 is what we want to compute. Okay, x plus equals to 2 times of abc, y plus equals to 2 times of abc, z plus equals to 2 times of abc. Now let's try to see only AB being there and the other things not being there. Okay, AB without C equals to AB minus ABC, and this will be, I think writing everything itself is easy. X plus equals to 3 times AB without C, Y plus equals to 3 times AB without C. So let me write that again. BC without A equals to BC minus ABC. Y plus equals to 3 times BC without A. Z, Z plus equals to 3 times BC without A. It's being weird, but yeah, I'm just writing it down. AC without B equals to AC minus ABC. X plus 3 times of ACWB. Z plus 3 times of ACWB. So for the struggle we have done A without B without C equals to A minus A intersection B A intersection C plus ABC. A minus AB minus AC plus ABC. X plus equals to 6 times A without B without C. In B without A without C equals to B minus BC minus AB plus ABC. Y plus equals to 6 times B without A without C. In B, C without A without B equals to C minus AC minus BC plus ABC. Z plus equals to 6 times of A. C without A without B. For, for struggling this much, I hope this is right. I wouldn't recommend writing such shitty codes, but it's contest. We have to be quicker, not make mistakes. What is happening here? Okay, total is being wrong. How can total go wrong? Total can never be wrong, right? So something is going wrong. Something adding to x, we are doing something wrong. So if you add them up, it should get cancelled almost. If you see ABC, you have 6 ABC, you have minus 6 ABC, minus 6 ABC, 6 ABC, minus 6 ABC. So the resultant is minus 12 ABC. And then you have plus 18 ABC. So plus 6 ABC. You have plus 6 ABC. So this seems correct, right? A plus B plus C minus take everything minus plus again add this one. So the summation seems right. ABC, ABC, AB without C, AB without C, BC without A, BC without A, AC without B, AC without B, AC without B, AC minus ABC, A, AB, AC, ABC, B, BC, AB, plus ABC. Why the fuck does this happen to me? Maybe the formula is wrong. A without B or B union C. A is surely there, B or C. Like this is nothing but A plus AB intersection B minus A intersection B intersection C. Only X being wrong sometimes. Okay, this should be right because there are some cases where no one is there, right? So this totally need not add up to that. But what about A not being full? This is cheating. Why am I getting stuck on such stupid problems? Now this is too much. I'll come back later here. There's nothing I can do. Oh, equals to is missing there. No, I need my specs. I don't look my best with specs, but fine. You're given an undirected graph of n vertices on M. The vertices are numbered from 1 to n, and then the graph contains no loops or multiple edges. Your task is to make a graph directed by choosing a direction for each edge. After directing the edges, call a sequence of vertices v1, v2, so on, vk, where k can be arbitrarily large and any vertex can be repeated a number of times. An alternating path if the edge is directed from v1 to v2, edge is directed from v3 to v2, edge is directed from v3 to v4 up to so on and so on. Call a vertex very beautiful if any path not necessarily simple in the original graph starts at v vertex v is an alternating path in the resulting directed graph. What about k equals to 1? So it says any vertex can be repeated any number of times. So what is an alternating vertex like? How do you define that? If something repeats again, you can re-repeat and then it just works. Okay? I mean, let's say you came to one vertex with pointing towards it and then you have to leave it with pointing towards it. Okay, let's just see like this. For any vertex, if it has two things pointing towards it, and if it has greater than or equals to 2 outgoing, greater than or equals to 2 incoming, then this vertex is good. You can come here and you can definitely leave from here, okay? What are the vertices that are bad? You can always do v1, v2, v1, v2, v1, v2 up to so on, right? So what's the answer? What's the complexity here? Then 4 and 0, the answer is 4. I don't get the problem at all. Let me take this example. 1523. 1523 is two pairs and two things are empty. So the problem is scamming. If you can just start from that, you can keep coming back and forth, right? So how is answer 1 here? How is answer 4 here? V1, V2, V3, V4. V3, V4, V4, V5. Okay, if any path, I should have read this carefully, beautifully. If any path in the original graph starts from V is an alternating path in the resultant directed graph. Any path should be that, it seems. Okay, now I understood the problem. Okay, for any path to be this one, what does that mean? For any path to be. So if you look at one vertex, if it is having an incoming edge, this is failing because take this path, that's failed, right? So, so if some vertex is good, it should be having all outgoing, okay? That's the first condition. And whatever is connected to that, this one, this is anyway failed vertex now. And this should be having all incoming, otherwise it will be gone, right? And this should be having all incoming, okay? Now you have this one, right? So the problem is you have few outgoing ones, and in the connected component, if there is something, okay, if this one is having both directions, then again it failed because you can take this path, then it's failing, right? So this means implies and implies all vertices should be either outgoing or incoming. So like you should split them into either outgoing or incoming. And if you see the graph, if every vertex is either outgoing or incoming, there cannot be an odd cycle, right? If there is an odd cycle, it is zero. It's not possible at all because all should be outgoing, all should be incoming, all should be outgoing, all should be incoming. And you take this one, it's failing. So there cannot be an odd cycle, first step. And if there is no odd cycle, you can choose outgoing ones to be maximum thing because it's a bipartite graph, whatever the bigger size is. So answer is like just that one, like try to find components, find odd cycle exist or not. If there is no odd cycle, try to find the size of the bigger component. That's it. Do BFS, find count of zeros, find count of ones, whatever the maximum among them is the answer. Okay. We'll handle them component wise, right? I'm trying to do BFS. After you take V, add V to this one, okay? d of a equals to d of v xor 1 and used of u equals to 1 and you push that to q. Now you try to go over all the edges. If not failed, then answer equals to maximum of number of zeros and number of ones. How do you do that? I can just write it here itself. The model is like quite not model, like what should be done is like quite common, right? This occurs many times, but the how the problem has been stated is okay. This was an easy problem. Let's try to read this one. It doesn't look that good, but let's try to read that one. For a positive integer x, the string s of x is formed through the following process. Initially, the string is empty. Initially, the string is empty. Then the decimal representation of string of the number x without leading zeros is appended to the right, to it on the right. After that, x, if x less than or equals to the process ends, otherwise x is replaced by the sum of digits of x, the process. So 75 is 75, 12, 3. Okay. As long as it is greater than that, it keeps happening. So this is an extra constraint we have. It is possible to rearrange it into this, it seems. So we have to see logically, okay, given that it is possible to rearrange and given that sum of lengths of s over all test cases doesn't exist 1 if I, how can you solve this? How can you find this one? Given that exists, some of this will come here and then some of this will come here and then some of this will come here and so on. One thing is it reduces very quickly, right? So whatever, okay, you can rearrange. So if you have x, so you have this one x f of x, f of x, and so on. All of them will have the same reminder z, 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 and so on. Can you find number of things that have been involved? What can you find in this one? What can you say for x and f of x, size of f of x? Let me just see the size of f of x, how it will look like. Can you find how many steps that have occurred based on the size? It is possible. Okay, given that it exists, how can you find now? You have to think of that. Given that it exists, and then you have to rearrange it like that. Damn. 75, 12, 3. Here, this is one thing, this is one thing, this is one thing. You should write in such a way that sum of these digits equals to the next number. You should split those digits into this chain sequence. So, what is so special about this chain sequence? All of them will have same reminder with that one. That is one thing. Okay? See, x less than or equals to something big, but f of x will be less than or f of x will be less than or equals to after just first operation 9e5. You see that? This is a smaller value. So from this, whatever the chain follows, from here onwards, because after first operation, the sheet is less than or equals to 9 times modulus of s. Okay, so because this sheet is less than or equals to 9 times modulus of s, and once you fix f of x, the subsequent is fixed. Once you fix f of x value, subsequent sequence is fixed, and you can determine their frequency counts prior. Okay, so now the problem is being done. Now, for given s, okay, brute force f of x equals to y. You're brute forcing this value, which is less than or equals to 9 times modulus of s. So in O of n, you're trying to brute force this value, and once you brute force that value, you know the frequencies of the remaining chain that goes. Okay, you know that. Because you know that frequency, you can remove that frequency from this, and then you can find the sum, and then you can verify if it is equals to y or not. Sum of digits of this equals to y or not, you will just check that. So you're brute forcing y, and it's possible to do the problem. You can find this for each of them, one after the other, finding frequencies of this for each of them. I can form them prior, or I can just form them here, because anyway it doesn't matter, right? Modulus of s is bounded. So I'll just write like this. We are brute forcing f of x because f of x is smaller. F of x is less than or equals to this one. We are brute forcing that one, okay? And the sum of frequencies of digits. We want frequencies of digits, okay? Sum will never be zero. So dp of zero will never occur, okay? But still, let it be there. So what do we do? Fi equals to f of I, let's say. Okay, this is the next number. All the frequencies from this chain plus frequencies of this chain would be the answer, right? So let's just say x equals to I, while x dp of I of x remained at 10. We are just taking count frequency counts. Okay, x by equals to 10. After taking frequency counts, we have to add fi's frequency counts. And then done. So we formed our fi. We have all our frequencies. Now we are trying to brute force y. See, y cannot be 0. Whatever the number you have, there exists a y, is what they told you. And y cannot be 0. Okay? So let's just have our current frequencies. Frequencies of s, let's say. Freq s of 10 comma 0, let's say. What I do, I'll just do the same thing. I think I should have written that one, but yeah, it's fine, I guess. Cassie as frequency of sc minus 0 plus plus. So we have this frequency, okay? While s is not equals to 9 times of n y plus plus. So now we will try to remove this frequency and then just see if the remaining sum will be equals to y or not, okay? Can you have the remaining sum before itself? You can have the remaining sum before itself in total sum. Total sum of digits. In pos equals to total, right? Total, from total you will remove all these things which are like easy to go over j and then just remove them. Now what I want is this sum should be equals to y is what I want. After you remove whatever from y it forms, this sum should be equals to y. This will happen to something. And once this happen, what we have to output is and what we have to output is once this happens, let's just output from 9 to 0. What is the count we have to output? The count we have to output is frequency of s of j minus dp of y of j k plus plus c out j. This will be not leading 0 because the sum is a positive value, right? I thought about that in my mind. And after outputting that, now we can start printing from y. y less than or equals to 9, written. Okay, break. It's brute force. When things looks complex, they are likely brute force. So yeah, 753. Okay, and then what sum of this will become? Maybe 7532. What happened? Okay, if here y doesn't exist, right? In this case, 12735, 1273. So y was 9, it seems here. Also, there is one other condition. Now we have 75123. We have one. We have everything being proper. So it's brute force. Just identifying that f of x is less than or equals to 9. That's not difficult. I know it will have 1,000 solves or something. Did I get it? Sum of fractions. Let's call an increase of a fraction x by y. Let's call an increase of the fraction x by y one of the following operations. Either increase its numerator x by 1, or if the denominator y greater than 1, decreasing its denominator by 1. So this is the increase. Okay, note that the fraction is not reduced after the increase. For example, if you have 3 by 7, you decrease the denominator by 1, you get 3 by 6, not 1 by 2. Ah, okay, I see. I see. You have two numbers x comma y. Okay, you either increase this or you decrease this, and they are not reduced. Suppose you are given an integer array b1, b2 up to so on bm and an integer k, you can apply the following algorithm. Construct the array 1 by b1, 1 by b2 up to so on 1 by bm. Choose any of the fractions and increase it. Repeat the previous step k times. So the same fraction can be chosen multiple times. So first you choose and increase it, okay, and then totally will do it k plus 1 times, because here you are doing once and then you are repeating k times. Calculate the sum of the resulting fractions. We will denote msf of b comma k as the maximum sum of fractions that can be obtained from the array b by applying the increase operation exactly k times. Okay, what's the maximum increase? I think maximum increase happens. See, initially all of them have a very small x values. So trying to x will only increase. X you can never decrease. So some things will reduce, some of both things will increase. See, if they're asking you to compute something that is so weird, then it is likely very simple. MSF should become very simplified. Okay. So for each K1, K2 up to so on Km, where they can be very big. Okay. M integers. M is big. This can be anything, and still you can find the value quickly, and not just find the value quickly, but you can find the sum for all subarrays very quickly. For each ki, you have to calculate this value, and then you have to output that. So if you have these many ki's, so you got that many ki's. So the problem is given to you. Now you have to think of the answer. So without loss of generality, let's just sort them in increasing order. You have 1 by a1, 1 by a2 up to so on. For 1 by b1, 1 by b2 up to so on. What you have to reduce to increase? If k equals to 1, what's the best thing that you should be doing? Okay, k equals to 0 is there. So for k equals to 0, it's making 1 by 2 as 1 is the best, right? So what is the answer? 1 plus 2 by 3 plus 1 by 5 plus 1 by 2. But then you have to find this for all summations, okay? Is it always reducing the minimum? You have 1 by b1, 1 by b2 up to so on, right? What happens if you reduce this one? It will become, what's the increase? Minus 1 by, so it looks like increasing the smallest one is better, and then it gets even better, and then it gets even better. So likely, greedily, and once it reaches, wait. You have this value, but then you also have the other options, right? To increase something on the top. So then it will become 2 by b1 or 2 by b2, up to so on. And you're never reducing them. Remember that. So is it always the smallest b1 that matters? Because you have this one, right? You will maybe reduce x to that, and then you will add y to this. Maybe this is the best thing that you can do, because increasing to the minimum is best. Reducing below reducing to the minimum is best. Always, even if that becomes 1. So it's all about minimum, like just minimum matters. And once you have minimum, you have to find when you have to stop. Okay? So once you have minimum, and once you have the minimum, all you have to think of now is, for different values of k, what will be this optimal x is what you have to think. Okay? If x is greater than or equals to b1, So for with respect to k, how this value changes? I think let's just look at this function itself, okay? With respect to k, x is number of things you have subtracted below and number of things you have added above. So k minus x things will be added above, right? Minus b1 plus b1, let's say. So now this shit is 1 plus 1 minus k plus 1 plus k minus b1 by b1 minus x. So this is the function 1 plus some constant and then it just keep on increasing. How does this function change? See, x as much as is the best. X x, yeah, as much as you can increase is the best. You can see that now. As much as you can increase is the best. And given x less than or equals to k. So this is a function where you have b1, okay? It's b1 minus x. So how does it look like at x equals to 0? It is like 1 plus some constant by b1. Okay? As you approach x equals to b1, it rises to its max, which is 1 plus that constant. And as you, if so it all depends on k greater than b1 or k less than b1. And for x greater than or equals to b1, we can see that optimal thing occurs at below thing will become 1 and we have reduced b1 minus 1, so we will have 1 plus k minus b1 minus 1 because b1 minus 1 has been reduced, so it will be here. So here it is quite constant. Here you know what it is. Here you know what it is. Right. So it is 1 plus 1 plus k minus b1 by b1 minus x, if x less than b1. So now think of if k less than b1. So x can be like x is less than or equals to k, right? So what is the best value to keep here? K itself. And what if k greater than or equals to b1? So this is definitely an increasing one. Keeping as big as x as bigger x as possible is the best one. It is 1 plus k minus b1 minus 1. It has some minus x or something, but yeah. So for a particular minimum of b1, you split the thing into two things. Now again you go to the next minimum and then you can just know the values. But you have to do range operations to the k based on this one. So you know, for if you let's you fix a minimum and then you divide the array into two things. So you know number of subarrays, for number of subarrays that will be contributed to this addition. You know that. We're only focused on increases, okay? Number of subarrays that this will be contributed, you know that. Fuck. Number of subarrays that this will be contributed, you know that. That much count will be added to all of. So fixing minimum, breaking the array into parts uniquely. Let's fix this one and then let's just say uniquely you broke them into two parts. Now among this you will try to fix the other minimum and then you will try to uniquely break that again and again and again. This breaking is O of n because after each break this breaking is O of n, and for each of this O of n you can do this one as you can do this increase. It's nothing but you have some z times 1 plus k minus of b1 minus 1, which is z times 2 plus 2 minus b1 plus k. So this you can somehow do that for all case. What about the other one? So if you add this one, it's like 1 by b1 minus k. If you add this one to the top, b1 minus k, 1 by b1 minus k less than b1. You have to add this much. This will be the increase, right? This will be the increase, right? Let's just look at increase. What's the increase from 1 by b1 if you do this? So even this you can do minus 1 by b1. So how can you add for various values of k this 1 by b1 minus k? But look here. If k is less than b1, this seems to be negative, right? If this value is negative, then it is x minus b1. Then smaller x is better. So maybe there x equals to 0 should be the case. Maybe. And if x equals to 0, then the other value will be. Okay, okay. If k less than or equals to k less than b1, right? So if you see here, if k is less than b1, then this value is negative. And if that value is negative, if k greater than b1, this is the best. If k greater than or equals to b1, if k is less than b1, then this value is negative or 0. And if this value is negative, x minus b1 is positive. So smallest x is the better. And smallest x is nothing but x equals to 0. So yeah, that's the case. That's why it's simple. So in other case, if k less than b1, answer is x equals to 0, which would give us, put x equals to 0 in this sheet, 1 plus k by b1. This much would be the increase. So both of these are just range operations. You add some k here, you add some 1 by b1 here to all the k. So that's it, guys. It's done. We have some case less than or equals to that. For that, you have to add 1 by b1. For the other ones, you have z by b1. For this, you have to add z. And for the remaining ones, you have to add that one. So you have to do range operations, some constants, some k coefficients. Okay? And then you are done. I hope this formula is perfect. And let's do this problem with some range operations. We have to sort case. And then what are we doing? Just range additions is what we are doing, right? So we have Fenwick tree. And what we do in the Fenwick tree, we take range, we take modulos everywhere. We don't even need Fenwick tree. It's like range addition. That's it. We don't even need Fenwick tree. Like, let me not even use Fenwick tree. We just want to do some range additions. That's it. I'm sorting them, and then I'll try to eliminate them. Let's say boundaries set. Let this set has boundaries. Okay, initial boundaries are -1 and n. Let's say okay, and now we'll go to the minimum, and then we will try to add that as boundary. We will see the previous two boundaries. We will get the count z. Okay, we got this value, and this will be contributing to the minimum of this one, this and this. Okay, equals to. So we have this pointed to this one. Okay, in right side boundary equals to star f. Let's say minus minus f. Left side boundary would be star f. Both will exist for sure. And then let's just insert idx also, because now that has been removed. And then we have z equals to idx minus l times r minus idx. This is the z. This is the number of subarrays that contain our index idx. And for all of this, minimum will be b1. And for all of this, you have to add what you have to add. You need two arrays, right? Let one be constant, let one be k. Okay, mx plus c. Let's say let one be constant, let one be m multiplier. Okay, let's initialize both of them to 0. And then once you initialize both of them to 0, all you have to do is some range operations for each of the k. Okay, right? So you have to first find less than or equals to less than b1 and greater than or equals to b1. Okay, you have to first find the k which is greater than or equals to b1. Find the first one greater than or equals to b1, which is nothing but so now you have g. Let's just say minus k itself. Now you have g idx j. Let's say so 0 to j minus 1 is one thing, j to m is other thing. So if this exists, what do? We add. So one thing we have to find is for each of the k, we have to find the initial summation. Okay, that what is initial summation? It's like just sum of all subarrays. It's just nothing but sum of fractions. Okay, we don't need ncr, we don't need factorial, we need modulus inverse, we need power, we need mod inverse mainly. So sum 1 by a0 occurs in oops, I have this multiplier. Let's just make it like mul. Can I code this in 15 minutes? You have this z, you have to add 1 by a1 times z to the sum. and this will be added to everything. Okay, the sum should be added to everything. That's what sum is. Now we are seeing here the increases. This is increases, and also this is increases. 2 minus b1 plus k minus 1 by b1. 2 minus b1 minus 1 by b1. Here it was just k. Here it is 1 by b1. I'll just bring those formulas down. So if j greater than 0, you have this first one. If j greater than 0, you have this one. You can add that. Okay, let's have 1 by b1. And then in this case, what you have to add? You have to add 1 by b1 minus 1 by b1 will get cancelled. You have to add z by b1 to mul of add. You have to add this much. You have to add that to 0, and then you have to subtract that from j. Even if j equals to 0, it just works out. You have to subtract it from. So that's what this one is. Now you are trying to think about this one. Okay? So if you see this one, the ranges are different here. Add equals to z times 2 minus b1 minus 1 by b1. 2 minus b1 minus 1 by b1. I hope this one is not wrong. You have to add this much to c, not mul, constant. C of j plus equals to add c of j remainder equals to m. C of m minus equals to add c of m remainder equals to m. Okay, now you have to change mul. What should be added to mul is nothing but z. Now what you have to add? You have to just add z to the mul because z times k, right? It is. Done. Everything's done. So finally what you have to do, you have to find for I equals to 1, I less than m, I plus plus, you have to update them. C of I plus equals to C of I minus 1. C of I remainder equals to m. Mul of I plus equals to mul of I minus 1. Mul of I remainder equals to m. And then what you should do? Answer equals to C of I plus mul of I times mod inverse of, it's k always. It's never 1 by k. It's just k. K of I. This should be right. This should just pass now and then I just submit it. I can't debug this shit. It passed. I hope nothing else goes wrong and this shit just gets accepted. I didn't even use Fenwick tree because I know it's just range operation. See guys, I have work, so I won't be trying to do G. This is good enough for me. I'll just leave now. Maybe I can do G, but can I? You're given a grid with n rows and m columns. You are controlling a chip that is initially in the cell 1, 1. In one move, the chip can move left, right, down. It can go to, the chip cannot leave the grid. You can make any number of moves. Let's define the path of the chip as a set of cells it visits at least once. Know that the order of visited cells doesn't matter. The task is to calculate the number of possible paths. Since the answer might be large, output it modulo n. So n can be large, but m is small. But you have to calculate it modulo mod. Modulo mod. Now I can flex my muscles. I can even flex my abs if they're there. I think one good contest in Eval. I hope my company doesn't fire me for not attending a meeting and giving a contest. I had a 30-minute thing today. It doesn't look that difficult, right? So it doesn't look that difficult. You have to take one thing, you have to take another thing, you have to take one other thing, you have to take one other thing. The condition is that each adjacent thing should have at least something common in between them. But you have to count this quickly. So for 2 cross 2, it's telling 7 is the answer, right? So you can take two things, okay? You can take two things, one thing, one thing. See, left, right, down. That's it. So you can take two things. Let's say you're coming here too. One, two, one, two. So three possibilities. Let's say you're not coming here. Uh, okay, let's say three threes are nine. Oh, you're here. You're here. One, two, three, four, five, six. Yeah, it's 2 cube minus 1. But now how does it propagate? Okay, it's just binary exponentation, isn't it? Let's say you have this one that you're coming till here, and then let's say you're coming till here, and you have some length in between. Okay? Can you find number of things by trying to cross product all of them? It's a direct problem. It's binary explanation and direct problem. Okay, you have this dp number of ways with this being active and this being active. Okay, and then you brute force trying to match. But you'll have 150 power 4 states. You have square of this one, that many states you will have. Maybe you have to define states better, like less than or equals to this or greater than or equals to that. If you define it in that way. Okay, I'm just ending it. I have to go. I'm just ending it.